Welcome to another episode of the MEGIN Spotlight series. Today we are joined by Dr. Matthew Rizzo, Dr. Olga Taraschenko, and Dr. Valentina Gumenyuk from the University of Nebraska Medical Center, UNMC.
Dr. Matthew Rizzo is the Reynolds Professor and Chair of the UNMC Department of Neurological Sciences, Chief Physician, Neuroscience Clinical Programs Director, Great Plains IDEA Clinical and Translational Research Network.
Dr. Olga Taraschenko is the Director of the Comprehensive Epilepsy Program, as well as an Associate Professor in the Department of Neurological Sciences.
And Dr. Valentina Gumenyuk is an Assistant Professor in the Neurological Science Department. She is a core director of the MEG Laboratory and in charge of clinical and research operations performed routinely in the MEG Lab at UNMC, Nebraska Medical Center. UNMC has a long history as a MEG site in the United States, being one of the first institutions in 2009 to utilize MEG technology. UNMC recently upgraded to MEGIN's TRIUX Neo.
UNMC utilizes MEG technology for both clinical services and research initiatives, and we look forward to discussing both areas with our Spotlight guests today. Hello, everyone.
Hello, thank you for inviting us.
Hello.
So the first question for Dr. Taraschenko, how does the Comprehensive Epilepsy Center use MEG in the operational flow of the department?
So the MEG is an integral part of our pre-surgical evaluation. We use it for both epilepsy surgery as well as tumor surgeries. So MEG allows us to identify epileptic networks and also map eloquent cortex prior to surgery. So we refer all our pre-surgical patients and then discuss the results at the conference. So far this year, we completed over 70 cases, and that represents an increase, probably a double from the previous year. It's very helpful for complicated cases, and we continue to utilize it not only here locally in partnership with Children's Hospital, but we also get referrals from the region, such as Kansas University, University of Iowa, and other epilepsy centers in the region.
Wow, it's amazing to hear about how many cases you've been doing this year. So Dr. Gumenyuk, how is MEG used in conjunction with other modalities, and how does this support both the clinicians and the patients?
Yeah, so the MEG, magnetoencephalography, it's pretty independent modality. So it can be used by itself, but in our lab, we're using MEG always with electroencephalography. We record patients with MEG and EEG settings. Specifically, we do 64 EEG electrodes we put for every patient who comes for the MEG clinical exam. We try to fight with artifacts which MEG can have in the data. And we also use EEG modality for reconstruction, the source we're looking for in research and in clinical settings as well. So for patients, it's very critical to have EEG data in addition to MEG, because our clinicians operate with EEG data sets. So we try to be accurate with MEG and EEG modalities. We also try to co-register with MRI and fMRI data sets. So we are kind of progressing with integration between different modalities in our settings in research and clinical studies.
Back to you, Dr. Taraschenko. Another question. Can you tell us about a case where prior to using MEG, a patient was not considered a candidate for epilepsy surgery, but the utilization of MEG allowed for this, actually?
Yes, actually, there were quite a few cases recently, just because we expanded the use of the machine. So, of course, you remember the most difficult ones, right? And so one recent example was a pediatric patient. And I particularly remember him because it made a clear difference. It clearly impacted his life. So this patient was suffering from severe seizures for number of years. He had autoimmune epilepsy, severe case, and was in and out of the hospital multiple times, including ICU stays. And so previously he was disqualified from surgery because both the family and his physicians were worried about losing residual language functions that he had as a result of surgery. So thanks to Dr. Gumenyuk's work and our MEG team work, we were successfully able to apply the MEG in pre-surgical testing. We actually, thanks to the MEG, realized that he not only has language function in the hemisphere where he also had seizures, but there's a little bit of language in contralateral hemisphere. So with this data, his physicians, his doctors and surgeon were confident to go for surgery, and he successfully completed the surgery last year. It really impacted dramatically his life. He was able to walk again and regain many milestones, cognitive and physical milestones that he lost during the years of seizures. And so we published this case. It was discussed at the national and local conferences, and it truly gives you a meaning for your work. And thanks to all the work, hard work from the MEG team, we try to impact one life at the time this way. And MEG was really instrumental in that process.
I love a successful story.
Yeah.
It's nice to hear that.
And what an incredible case to share with us. Thank you. So Dr. Gumenyuk, is MEG technology also part of any epilepsy research ongoing at UNMC?
Yes, we're trying to develop research projects in epilepsy area because we think that MEG is a very, very important tool to not just do clinical evaluation, but move forward with research ability to show the MEG can do much more than in current stage. So we're developing a lot of pipelines. We are collaborating with my previous work group at MGH, and we do still continue some developing of pipelines to understand network for epilepsy disease. So we do connectivity analysis, we do causality analysis, we try to develop language that can be also map area of language network in very hard patients who cannot cooperate and cannot follow your command. So we're working on these areas where we try to pick up the gap, which is now exist in research and the clinical MEG settings, and try to fill it in with our data.
All right, thank you. Dr. Rizzo, it's your turn to answer a question now. How is MEG utilized in the Neuroscience Center across different areas of research?
MEG is a wonderful tool for research, and we're so glad to have the new MEGIN tool, and so glad to have Dr. Gumenyuk with us, working and developing our capabilities. The MEG is sort of multi-capable. We use it for clinical purposes, for education, but also for research, which is your question. And there are a lot of applications in research. We have applications for using MEG as a biomarker for cognitive impairment in neurodegenerative disorders. Valia had mentioned using a MEG in epilepsy and also, by the way, in brain tumor research. There are also ways of using MEG to probe social interactions and dyadic interactions, like between caregivers and patients. And in these instances, you can actually pair MEG with other modalities like fMRI or MEG, and we're exploring all of those possibilities. Another thing is there are useful and fruitful applications of MEG for exploring neurodegenerative impairments and sleep. Examples include Alzheimer's disease, Lewy body dementia, and frontotemporal dementia, which are very vexing conditions that we need to understand much better. MEG is being used for surgical planning of epilepsy surgery in adults, even in children who are as young as a year old. And in that, we have a robust and a productive relationship with a children's hospital here in Omaha and with the Children's Health Research Institute. We're developing collaborations outside of UNMC. UNMC, you can see from the background here, we're the headquarters for the Great Plains IDEA, which is an institutional development award from the National Institutes of Health, and lots of other institutions spanning the region and the nation. Locally, that includes a developmental institute called the Monroe Meyer Institute, in other parts of the University of Nebraska system. That includes the University of Nebraska at Lincoln, and in particular their Center for Brain Biology and Behavior, which is doing a lot of neurosciences, including imaging research that's compatible with our MEG interest. Also, data are kind of the oxygen that we breathe these days, and plenty of it comes from imaging. And then we need robust applications in AI and machine learning to know more about and recover the signal on what's happening in our MEG data. So we're going to be learning more about temporal and spatial specifications from MEG data related to sleep and cognition and pathology in the MEG studies that we're doing. So we are very enthusiastic and excited about MEG. It's a wonderful tool, just like a microscope and a telescope were for making new discoveries. We can peer into the brain with great temporal resolution and pretty good spatial resolution into the deep structures of the brain, covering every place. And that's what we need.
It's great that you're using the MEG device in so many different ways and in so many different aspects. I think that's amazing. That's great.
Dr. Gumenyuk, at UNMC, is MEG being utilized in research with patients with memory disorders? If so, why is MEG a useful modality for this? Are you able to elaborate more on this in your findings?
It's a good question. Thank you for asking that question. Yeah, memory disorders is very, very prevalent, and it's very comorbid with neurological disease, which we're interested in our lab and our department. We actually have a new faculty here who is interested very much in memory, especially auditory memory. And we know auditory field is impacted by aging, and also is impacted, memory itself generally impacted by abnormal sleep. So we try to combine together sleep, performance, and aging to look at the trajectory, how memory can decline due to these abnormalities in the brain, happen due to sleep and neurological disease. We're also planning to apply some pilot grant to collect the data, which we will submit to National Institute for funding for bigger study, because we have a variety of clinical cases. We can track the memory differences, abnormal memory difference across disease. So we can potentially find a kind of biomarker specific for memory deficit in each neurological disease we have in our plate. And yes, we are very enthusiastic about memory function here to show the epileptologist where the where's the memory dominant hemisphere for this patient. So when they proceed with the surgery or planning of the surgery. So memory studies is very important, and we are trying to use MEG system very wisely for that field.
So a question to both of you, Dr. Rizzo and Dr. Gumenyuk. Are you able to share more about the sleep disorders research you are conducting with MEG?
So I'll kick it off. I think Valia has boots on the ground and many of the details. So I will say in general that we are studying sleep in a normal and abnormal states in the brain. In clinical MEG studies, we're using specifically designed sleep protocols. I'm going to let Valia talk more about the details of that. Go ahead, Valia.
Thank you, Dr. Rizzo. Yes, we developed specific protocol, which called sleep protocol for epilepsy patients, where we can see more nicely interictal activity. We are basically mapping to show epileptic network for our physicians. Without this protocol, the MEG study would be very much negative. And that's what I hear from other MEG labs when they not apply sleep protocol for this type of the study, the results could be negative. Basically, they cannot find anything in the awake brain. We're also interested in the research to study sleep onset, because sleep onset is actually very much linked with insomnia and sleepiness. And especially with neurological disease, in our study, we're using sleep recording not just in the MEG system, we record actigraphy for 2 or 3 weeks because we want to correlate the habitual sleep with the data we collect briefly in the MEG system for 20, 30 minutes. So we are kind of exploring this area. Sleep is very difficult field, and it's very difficult to analyze this data. So we are trying to find a more robust results, which can be differentiate sleep onset between type of dementia. And also, as Dr. Rizzo mentioned, we are kind of exploring more and more sleep protocol and developing sleep protocols for our clinical studies, so that our data will come more fruitful and useful for clinicians. And if Dr. Taraschenko wants to add something.
Yes, I agree with Valia that sleep is difficult to discern from the rest of the background. So a lot of the neurological diseases are exacerbated by sleep, or we can detect them better in sleep. So it's great to have yet another modality with good resolution, both temporal and spatial, to study these conditions in a more broad kind of range and with high precision.
I would like to add to what Avalia and Olga said, that in these studies of sleep in patients with different conditions and cognitive abilities, there are a number of independent variables that we need to take into account. Also, we're triangulating in on patients using MEG, but also with other data like demographic data, data from other imaging sources, data from the exposome, which has to do with all the sum total environmental factors that impact a person's health. And those are internal factors, including microbiome, and external factors. They include proteomics and genomics. We have to make sense out of this ocean of information. So I think any sort of modern neuroscience department that uses MEG is going to be needing to use novel techniques to try to recover signals and test hypotheses. And so that we are recruiting faculty who are expert in machine learning and AI to help us recover data on our patients in whom we're deploying MEG to understand better things like the sleep abnormalities that we were talking about, and evolution of disease or improvement of disease with interventions like, for example, new biological therapies as in Alzheimer's disease, or non-pharmacological interventions such as music. So lots of work to do, and MEG is helping.
It's great to have heard from all three of you on that question as well. Thank you. So Dr. Rizzo, as mentioned at the beginning of this spotlight, UNMC has had an MEG program for close to 15 years. How is MEG part of your curriculum for medical and research students to learn more about this modality?
I want to say we're glad to have had MEG. It antedates my arrival here, which was about 9 years ago. And I think the program has grown and developed traction and gained purchase over the years as a better understanding of the tool has evolved regionally and nationally and internationally. Part of bringing along the next generation of neurological caregivers and neuroscientists is sort of building the pipeline and educating people on new techniques as they develop. And so we take that seriously. And so there's a potential learning experience and exposures for students, whether they be medical students or graduate students, fellows in epilepsy, for example, neurosurgery residents, and so on. And so this has been an evolving process, and our students have engaged in MEG research, learned the value of the tool, been able to become part of presentations like platform presentations, abstracts, and papers. And in that, they gain an appreciation of this modality, how it fits in with their practice, and how it can catalyze new research for new discoveries that can be targets for potential therapeutic efforts in the future, identification of early disease for early treatment, and so forth. So we think this is very important, engaging students and developing the next generation of MEG users, neurological caregivers. And I'm planning to work with MEGIN to become a national training MEG center for new MEG users. We're excited about it. We have everything we need to train new MEG users in clinical and research settings, and we're ready to go.
Well, that's exciting for us too.
I wanted to add about the fellows. Having a MEG center is definitely a selling point for the fellowship candidates. I got to interview a lot of them every year. And so they are excited, the candidates are excited to hear that this epilepsy center has a MEG lab that has a modern device that will allow them to do research. So all our fellows rotate at least once for an elective, at least for 1 month during their fellowship training through the MEG. And as Meg said, it resulted in a number of abstracts, high quality publications, and even residents who are particularly busy. Those are people who work nonstop. They still are so fascinated with MEG that they find time to work with Valia and submit papers and abstracts to the national conferences.
Oh, that's great. Well, we're excited to have you, collaborating with us on that. So that's really good news. So we've come to the last question now. Dr. Gumenyuk, just for you, now that you've upgraded from an older MEGIN system to the TRIUX Neo, can you please share your experience with the internal helium recycler, the IHR? How has this helped to improve operational costs and efficiency?
Well, I think it's a genius part of the MEG. I think because I've been in the MEG field for 15 years, and every week was deal with refill of the MEG system. And that takes a lot of time, like 3-4 hours to get it done, train personnel in the lab, train staff, get this helium delivered, and, be in distress when it's not delivered. And also it's costly. So it's labor and cost is very high with all type of machines. But this helium recycle, it's a very genius product from MEGIN, which we love it. All of us love it. So we have 1 year of helium recycle in our lab. And basically we had no issues with helium anymore. We did not order any helium extra. Because you can use helium as a gas, which is much less expensive if something happened with helium recycle as a maintenance. And so, yes, it's a very, very needed a part of the MEG system. And it's a unique, I think, a component, which is very smart. It takes care of helium itself. So you don't need anything to add from your part of the day that you come to work. You just need to check how helium level is present in the system. And my personal grateful thanks to MEGIN engineer. So if anything happened, and it's very rare, but it can happen. So we call engineers to MEGIN customer service, and they right away on the phone and helping us quickly to fix it. So we never had any issues to miss our study, which was planned, or any warm-up situation which happened before. Warm-up means the helium lost in the machine. So we're very happy about that part of the developed project from MEGIN. Thank you.
No, thank you. That was a great testament to us too. So thank you very much for mentioning that. So we've come to the end of our spotlight today, and we are very, very grateful, and thank you very much for everyone's time. It's been really informative. The interview will be very, very relevant to our audience. And we look forward to sharing all these updates from UNMC in the future with our audience and with our key opinion leaders like yourselves in the field. So thank you very, very much for your time today.
Thank you.